Okay, I'm going to talk a little bit about the idea behind completing the square. And the reason that we need to complete the square, well, one reason we need to complete the square that I've been running into lately with some students is writing the uh, standard form of conics. So, for example, if you're given a circle in the general form and you want to write it in the form x minus h squared plus y minus k squared equals r squared, you need to be able to complete the square. Let's suppose that we have a variable expression x squared plus 6x. So what I've done here is I've just shown on the left side, I'll put it in a rectangle. I've just shown what happens if you take that expression and plug in various values for x. If you plug in -1, you square -1 and add 6 times -1, you get -5. If you plug in 0, you get 0. If you plug in 1, you get 7. If you plug in 2, you get 16. Two of those values are perfect squares, but two of them are not. So in general, we cannot say that x squared plus 6x represents always squared values. And one way to think about that, one way to represent that visually, is to think of something that has an area equal to x squared plus 6x. So we could think of that as being like something like, let's say x represents some quantity, which means x plus 6 would also represent some quantity. And let's say we were building like a fence that was x units by x plus 6 units long, where x could be any value, at least that made it a positive area, which I realize my values over on the left side aren't always positive. But anyway, let's say that we're thinking of it as a rectangle that is x by x plus 6. And if you're wondering how I got that, let me just make sure that I make that clear. If I take this variable expression and factor out an x, it leaves me with x plus 6. Okay, so I get this rectangle. It's a rectangle where one length is 6 units longer than the other length. Well, let's say I want to change things around a little bit, but I don't want to change the amount of fencing that I have, but I want to make it a square. I want to make this into a square. So in order to make this into a square, let me draw a square, or at least close to a square. What I'd have to do is I'd have to take away half of this 6 right here. Whoops, wrong tool. I'd have to take half of this 6 here and give it to this x over here so that they would be the same length. So if I took half of that 6 away on the bottom, then I'd have x plus 3. And if I gave it to the side over here on the left, I would get x plus 3 also. So now I've created a square. Now, one thing that's really important to understand is that these areas are going to be different. It's true that for a quadrilateral, the shape for a given perimeter, let's say, which these two have the same perimeter. If you added up the side lengths for all 4 sides, they'd have the same perimeter. But for a given perimeter, the square maximizes the area. So I did change the quantity. For example, over here on the left side, let's let x equal, let's say 5. Okay, if I plug in 5, my area would be 5 times 5 plus 6, which is 11. So my area would be 55 square units. Whereas down here on the bottom, if I plug in 5, I'd have 5 plus 3 times 5 plus 3, which is 64 square units. So it's important to reflect the fact that I know that when I change around my units like this to make this into a square instead of a rectangle, that I am in fact also changing the quantity that this area represents. So in other words, I'm going to take this example x squared plus 6x here in a second and use it in a problem that we might run into with conics and show you what needs to be done to compensate for the fact that we have changed the quantity. So let's take a look at an example. Let's say that we are given this equation, x squared, to keep it very simple, plus y squared plus 6x plus 8y is equal to 0. And I need to write that in the standard form for a circle, which this isn't about conics, but I'll just give that to you real quick. The standard form for a circle is x minus h squared plus y minus k squared equals r squared. Okay, so procedurally, the first thing that you do is you bring your x terms together. Now we're going to leave a little space there. Put your y's together and leave a space, and then 0 over on the right side. Now remember what we did a minute ago with the x squared plus 6x. To make it into a square, we had to take half of that 6, which is 3, and square it. So that added 9. Now remember the difference between the square of the rectangle and the square of the the area of the rectangle and the area of the square. The difference was 9. And that's because we just added 9 in order to complete the square. So we're going to add 9 over here. Same idea with y squared plus 8y. I'm going to make it into a square instead of a rectangle. I'm going to take half of that 8, which is 4. I'm going to square it. 4 squared is 16. So now we can factor x squared plus 6x plus 9 as what we call a perfect square trinomial, which you could see from the previous example that I showed you with going from a rectangle to a square. We made it into a perfect square. Plus y plus 4, the quantity squared, equals 0 plus 9 plus 16 is 25. So again, this isn't about this isn't about conics, but this would be a circle with a center at -3, -4, and a radius that was equal to 5. So that little illustration shows you why completing the square works, and there's an example of utilizing the procedure of completing the square to complete the square to write a circle in standard form. So hopefully that solidifies your understandings a little bit, or maybe a lot, about why completing the square works and how to do it.